And Brittany, are there more people coming in now? Okay, while I pause for a thumbs up, I will tell you that my name is Dave Brain, and I'm really proud to be the chair of the Department of Astrophysical and Planetary Sciences here at CU. Are we good, Tito? Okay, great. Off we go. Graduates, family, friends, faculty, and staff, welcome to all of you, and thank you for joining this very important occasion. We're here at this certain place, at this certain time, to celebrate you and your certain achievements. But it would be disingenuous of me not to acknowledge that it is a time of great uncertainty for many of you, for many of us. Uncertainty is not typically a pleasant feeling, but it is one that you know that scientists live with every day. Uncertainty is a defining characteristic of a good scientist, embarking on an exploration into topics and ideas for which there are not yet answers. A good scientist is never certain. Nevertheless, maybe it would help right now for me to tell you about a few things that I am certain of. First, I am certain of the value to you of having studied astronomy, the skills that it has provided, the critical thinking muscles it has flexed, the ability to think about large, difficult, abstract problems that will serve you well regardless of what trajectory you take in life. Next, I am certain of the importance and benefit of continuing to expand the frontiers of astronomical knowledge, the value of understanding the universe from the largest to the smallest scales that no one else on this campus can claim, of the technological advances that result from progress made in our field, and the ways in which astronomy research, from astrophysics to planetary science to solar physics to space physics, makes life better for all people on this planet. Third, I'm certain of the less tangible importance of astronomy to society, beyond the technical advances, the insights about where we've been and where we're going, whether we're alone in the universe, the sense of perspective it brings, and how this perspective reinforces the importance of being kind. These are great things for you, for our field, and for society, and it comes at low cost. Out of every $100 the average American pays in taxes, about 50 cents goes to NASA, down from a peak of $4.40 during the Apollo era. Of those 50 cents, 15 to 20 cents goes to science. About 10 cents out of every $100 goes to the National Science Foundation, 60 cents or so to the National Institute of Health. Low cost, big benefit. And the good news is that Americans think favorably of scientists. Something like 75% of Americans think favorably of scientists. The bad news is the percentage of Americans who say they have a great deal or fair amount of confidence in scientists has decreased by 10% since the pandemic. 89% of Americans think scientists are intelligent. Good job. 45% think they are good communicators. 47% think scientists feel superior to others. For me, these statistics underscore the importance of a 5-word phrase that some of you know that I share at least once in every class that I teach. Science without communication is pointless. You could be the most capable scientist in the world, but if you cannot or do not communicate what you learn, it was a purely selfish endeavor. What was the point? Science without communication is pointless. Living this phrase, being an ambassador for astronomy and for science in general, is now your charge. No matter what you do in life, no matter where you are headed next, in the next hour, you will graduate from this department trained as a scientist. You, whether you like it or not, are an example to others for the rest of your life of what a scientist is. Maybe in your job, maybe to your relatives, but also when you least expect it, in random moments and encounters with others you will never see again. I know that you will carry yourself well in these moments. You will leave people with the impression that a scientist is a person, like anyone else, that a scientist is not other, that a scientist is curious about important questions, that a scientist feels and has opinions, but is able to dig through their feelings in an unbiased search for understanding, that a scientist has the humility to admit when they were wrong and change their mind based on evidence, and that this is a virtue and not a weakness. This is a weighty request. It's a lot of responsibility, made a little lighter perhaps by the fact that you get to represent such a wonderful, beautiful, and awe-inspiring field. So before I close, I want you to take 10 seconds, graduates, and think about something wonderful, beautiful, or awe-inspiring that you have learned about in this department. Anyone else in this theater with a science degree is encouraged to do the same thing for your field right now. Wonderful, beautiful, or awe-inspiring. I'll give you 10 seconds. Did you think of something? On the count of 3, I want all of you to say the thing that you were thinking about out loud, all at the same time. 1, 2, 3. I may be a scientist, but I am now certain that you are up to this task. I speak for the faculty and staff when I say that we are so very proud to have gotten to know you and watch you grow during your time in APS. We hope that you keep in touch and continue to feel that you are part of our community once you have left this campus. Thank you for your attention. Next, I'd like to call up Sylvan Arnold, who will be making an astronomy presentation along with Ray Ramos, who will be navigating.
Thank you, Dave. And thank you to Ray, who will be controlling all of the visuals we see on the dome for this astronomy section, and therefore really taking us on this tour through the universe. And I'd like to thank all of our faculty, all of our graduates, and anybody who's here today to support us for all of our hard work, dedication, and support over the years that has really taken us this far. Before we begin to venture out into our universe, I'd like to call your attention to our exit sign, which is not above these exit doors. So if you need to leave during the darkness, please take a step to the right of the exit sign. Would also like to ask that during this section, just this one section where it will become very dark, that you refrain from using any flash photography. But where better to begin here than with our sky? That sky that has doubtless inspired all of us and is probably the reason that many of us are sitting in this room today. And so we begin with our daytime sky as we would truly see it from Boulder. But I think that it would be all the more fitting if we took a bit of a transition and instead of staying here at our daytime sky that we all just walked out of, if we traveled through time to our nighttime sky to see those stars that have inspired us and all of humanity for generations. So as we watch our sunset in the west, we see our nighttime sky with our stars, tonight our gibbous moon. And in these stars, humans have created constellations. And we've used these over the years for various things, for storytelling, for timekeeping, for navigation, and for showing us different portions of our sky. And in these stars, we noticed even a few wandering stars, a few stars that didn't quite follow the rules, that didn't stay in those constellations. We have just 2 of these wandering stars in our night sky tonight. Today we know them by the names of Mars and Jupiter, and we refer to these as the planets inside of our solar system. And slowly, piece by piece, we managed over the years to piece together a more complete picture of our solar system that looks more familiar to what we think of today. And humanity, through hard work and dedication, is no longer constrained to just the surface of the Earth, to just looking up at the stars and wondering, although they do still fill us with wonder. So let's take advantage of all of the hard work that's come before us and take our own journey into our universe. So as Ray lifts us off the Earth, we will be able to see a view of the Earth that few humans have ever truly seen. And right about there is Boulder, is where we came from, is where many of us have spent the past 4 years, perhaps spending the night at SBO or at Duane, going through problem sets, trying to even figure out which door to Duane is unlocked and will let us in. But now, we can leave that all behind for just 1 second and travel far away from all of this so that we can remember what all of this hard work and dedication was really for. And as we head away from the Earth, the first thing that comes into view is the orbit of our moon. Our moon, the farthest away from the Earth that any human has ever been. And yet we still observe things so much farther away. And so here we begin to see all of our other planets coming into view, with our sun at the center, our 4 inner rocky planets, Mercury, Venus, Earth, and Mars, followed by our 4 outer giant planets, Jupiter, Saturn, Uranus, and Neptune. And we have sent spacecraft for at least a flyby to every single one of these planets, every single planet in the solar system. But planets are not the only constituents of the solar system, and we would be remiss to neglect what is perhaps the star of the show, our own sun. And that is why, in 2018, the Parker Solar Probe was launched to enter the sun's corona, to literally touch the sun. And just this past December, Parker Solar Probe made its closest approach to the sun, flying through the corona and breaking records to become the fastest ever spacecraft created by humans. And so through studying our sun, we can see more about our star and perhaps more about stars that are just too far away for us to touch, just out of reach. The Parker Solar Probe is an incredible piece of technology because of the proximity it reaches to the sun. It has to be able to withstand extraordinary temperatures. But our solar system is a diverse place, and there is something to be said about not just the incredibly warm temperatures near the sun, but also some colder, icier regions of our solar system. And so, just last October, the NASA spacecraft Europa Clipper was launched to head towards Jupiter, towards an icy moon of Jupiter known as Europa. This follows the launch of the ESA spacecraft JUICE, the Jupiter Icy Moons Explorer, by just 18 months. And together, these spacecraft will head towards Jupiter and explore these icy moons and tell us something about their formation, about their geology, and perhaps about the potential for life outside of the Earth. And these four moons that Ray has made large for us are known as the Galilean moons. They've been known about since Galileo's time. They're visible through a small telescope. And so moons in our solar system is something that we've known about for hundreds of years, besides our own, which we've known about for much, much longer. But even something as simple as planetary moons can still offer so many surprises. You see, when we began this semester, Saturn had the most moons in the solar system already, an incredible 146 moons. But through meticulous observations, it was announced as recently as March that many more moons of Saturn had been discovered, bringing the new total number of moons of Saturn to 274. So even something that seems as simple as the number of moons in the solar system is something that can change if we really dedicate time to it, if we really dedicate these observations. And as we head further and further out into our solar system, I'd like to note that in the year 2021, the James Webb Space Telescope launched. This telescope observes infrared wavelengths, and although that has many applications in terms of finding faraway galaxies close to the beginning of the universe, it also offers a lot in terms of what we can see inside our own solar system. For the first time recently, we were really able to use the James Webb Space Telescope to image auroras on Neptune. Neptune's auroras had been a bit of a mystery. We can see this Hubble Space Telescope picture on the left. Doesn't show us too much about them, but if we combine it with observations from James Webb, suddenly an entire new world lights up. And as we head further and further out, farther than any human-made spacecraft has ever traveled, our observations do not end here. We are not constrained by where our spacecraft can go, although they are most certainly helpful in our observations. Telescopic observations tell us about the rest of our galaxy and the rest of our universe. And as we get farther and farther away from our solar system, I'm going to ask Ray to put up all of the IAU-defined constellation lines. And these are stars that humanity has known for millennia and has looked to for millennia, but as we travel farther and farther away, it seems that even the stars themselves begin to shift. There is a certain enormity to our Milky Way galaxy. As we get farther and farther away from our sun that I frankly can't even see anymore, we'll begin to see the rest of our Milky Way galaxy, the rest of it that is not included in these constellations because the stars are too dim or too far away. And our galaxy contains 100 billion stars, and perhaps 100 billion planets, most of them still waiting to be discovered. And we've pieced together a picture of our galaxy that looks something like this. But our Milky Way galaxy is not alone in the universe. We're part of a small group of galaxies known as the local group, containing 50 to 100-ish galaxies, with only a few large galaxies, of which we are one. But as we get farther and farther away, we're able to see galaxies from more intense galaxy surveys. In recent years, we've been able to map tens of millions of galaxies. And mapping these galaxies, it doesn't just tell us about the galaxies themselves. It doesn't just tell us what different shapes they are, what different structures they are, what different stages of evolution they're in, how they might be different from our own. It tells us something about the universe itself. And once we get far enough away from the Earth to really see more galaxies than we can fathom, because each of these points of light that we see here is an entire galaxy made of billions of stars, we can start to see structure in the universe. And the structure of these galaxy clusters tells us something about the way that our universe has evolved over time. Because the light from farther away galaxies takes longer to reach us, it shows us a picture of our universe from a long time ago. And so we can see over time how it has changed. And there really is an unimaginable wealth of knowledge in this data and in all of the data that has yet to be gathered, has yet to be analyzed. Our universe is an incredible place, and we have only just begun to scratch the surface of what might be. So whether our interests lie in cosmology, in galaxies, in planetary science, in solar or stellar physics, each of us truly has a place to imagine, to wonder, and to learn. And even as we leave this university, as we leave this place, we are always going to be able to carry that wonder with us. And we're always going to ask the next question and see what is left to be uncovered. And the beauty in it is, we'll never reach the end. So congratulations to all of our graduates, and I hope that in the coming years, some new discoveries are uncovered that tell us something more, something that we never imagined about our Earth, our solar system, and our universe. Thank you.
Thanks so much, Sylvan and Ray. That was wonderful. Can we give them another round of applause, please? Okay, next I'd like to invite to the podium our APS undergraduate speaker, Rana Osman.
As I reflect on my time here, I think of the countless faculty, staff, mentors, peers, friends, and family members who have been crucial to my development as an astronomer, researcher, and human being. I know the same is true for all of us. In the last 4 years, I have learned a lot about gratitude and how often people take it for granted. As we enter the next chapters of our lives, I want to stress how important it is to show appreciation for those around us. And I challenge all of us to take this time today to think about and thank all those that played a role in our journeys that landed us here. I personally would like to give a blanket thank you to everyone here, to everyone who has made this day and everything leading up to it possible. Without this group of people by my side, I wouldn't be who I am today. I've learned that when you're lost, you can always lean on those around you, especially those that came before you. The guidance of those that you look up to, your role models, is invaluable. I found strength in carrying pieces of them with me, using their example to shape the person I want to become. And all that they have endured grew to be inspiration for me, inspiration I didn't know I would have to act on so quickly. 7 days after the beginning of this semester, our last semester as undergraduate astrophysics students, on January 20th, the clock started on a different 4-year period. And since then, we have all been tested and challenged in new and devastating ways. While the last 4 years have challenged us academically, mentally, emotionally, and physically, the challenges and the situation of the national scientific community over just the course of this final semester have challenged us all in ways some of us never could have prepared for, in ways that are disheartening, and in ways that are still uncertain. Frankly, I'm scared. I'm afraid for what the future holds for us as scientists, researchers, educators, and as compassionate human beings. Many of our futures already feel like they have been derailed from their true course. But I'm also hopeful. Just by getting to this point, we have proven ourselves capable of overcoming great obstacles. We didn't know it at the time, but this degree we have earned has prepared us for this moment. As we learned how the planets formed and how galaxies die, we also learned resilience, persistence, critical thought, and compassion. If these last 4 years have done anything for me, they have proven that I am prepared for the next 4, and that we will course correct. To practice what I preach as a representation of honoring and modeling myself after my role models, and as I am, when I am lost, and as a tribute to our humanity, I'd like to wrap up my time with you all today with some words from Carl Sagan, which I first heard at the end of my first semester at CU from Professor Dave Brain on the last day of Intro to Astro 1. I don't know where it is because I can't see. Oh, it's right there. Okay. Many of you may be familiar with this image, but for those of you who are not, on February 14th, 1990, as Voyager 1 was leaving our planetary neighborhood for the fringes of the solar system, it turned around for one last look at its home planet and took this image, dubbed the pale blue dot. Look again at that dot. That's here, that's home, that's us. On it, everyone you love, everyone you know, everyone you've ever heard of, every human being who ever was, lived out their lives. The aggregate of our joy and suffering, thousands of confident religions, ideologies, and economic doctrines, every hunter and forager, every hero and coward, every creator and destroyer of civilization, every king and peasant, every young couple in love, every mother and father, hopeful child, inventor and explorer, every teacher of morals, every corrupt politician, every superstar, every supreme leader, every saint and sinner in the history of our species lived here on a mote of dust suspended in a sunbeam. The Earth is a very small stage in a vast cosmic arena. Think of the rivers of blood spilled by all those generals and emperors that in a glory and triumph, they could become the momentary masters of a fraction of a dot. Think of the endless cruelties visited by the inhabitants of one corner of this pixel on the scarcely distinguishable inhabitants of some other corner, how frequent their misunderstandings, how eager they are to kill one another, how fervent their hatreds. Our posturings, our imagined self-importance, the delusion that we have some privileged position in the universe are challenged by this point of pale light. Our planet is a lonely speck in the great enveloping cosmic dark. In our obscurity, in all this vastness, there is no hint that help will come from elsewhere to save us from ourselves. The Earth is the only world known so far to harbor life. There is nowhere else, at least in the near future, to which our species could migrate. Visit, yes. Settle, not yet. Like it or not, for the moment, the Earth is where we make our stand. It has been said that astronomy is a humbling and character-building experience. There is perhaps no better demonstration of the folly of human conceits than this distant image of our tiny world. To me, it underscores the responsibility to deal more kindly with one another and to preserve and cherish the pale blue dot, the only home we've ever known. Thank you.
So I'd like to announce that I am hereby retiring, and Rana will take over for me for the rest of the ceremony. Nice job, Rana. Okay, with that, let's get to handing out diplomas. So I'd like to invite to the podium Professor Anne-Marie Madigan, who is the Associate Chair for Undergraduate Education.
Thank you, everyone. Graduating students, you will now receive your diplomas. When you hear your name, please come up to the stage. To receive your diploma, shake hands with Professor Brain. I just want to stop and say that again. Professor Brain, so good. And pose for a photo. You're also very welcome to say a few words, if you'd like. Parents and friends, please feel free to move about to get the best photo you would like. Now is your opportunity. And I also want to say we additionally have a couple of students graduating this year with Latin honors. So the College of Arts and Sciences each year awards Latin honors to students who do original research and write up a thesis and successfully defend that thesis to a committee. The award is based on a combination of GPA and their research. I will announce the Latin honors designation beside those students' names. Finally, a word on etiquette. Whooping and loud clapping are encouraged. Thank you very much. Okay, let us get to our list. First, we have David Abbey.
I think we go.
Enoch Adams. Jackson Arn. Shara Beakley. Sydney Sechanowitz. A reminder, you can say a few words if you would like. Anyone. Next week.
If you're giving me the mic, I can speak. Hi, I'm Sydney. I've loved my time at CU, and I just came from my geology one, so that's why I kind of just ran in the doors and came on the stage. So thank you guys.
Ryan Dick. Garrett Dinsmore. Burke Edwards. Hannah Ferrero. Jake Hammond.
There's a few people I need to thank today. First, my mom traveled a long ways to come here, so thank you for coming, and thank you to my wonderful, lovely wife who puts up with me because I'm quite a handful. Thank you.
Joe Harrison.
I would like to briefly thank my family and friends who were able to come out tonight and support me through this entire endeavor. And thank you, Tito and Nick, for bringing me on to this wonderful Fisk team and the last 2 years I've worked here.
Griffin Keener. And for an astronomy minor, Juliana Kelly. Delaney Lee Bellows. Avery Mazurkowitz.
I would just really briefly like to say thank you to John Keller, to Dave Brain, to David Malaspina, and to Nick Schneider for your mentorship, and thank you to this department for shaping me into who I am today. I want to say that I'm proud of my mistakes and my failures that have brought me here today, and I'm proud to be a scientist. Thank you.
Evan McPherson. Clayton Miller.
Thank you.
I can just scream.
there it is.
Oh, okay. I won't scream now. I was just saying we love the self-organization. This is beautiful. Jay Meisner.
Oh, to quote Clayton, thank you.
Rana Osman, summa cum laude. Melaine Perry. Ryan Fu.
Stand strong, stay true, stand on business.
Matthew Rickner. Deanna Rose. Grace Shore.
I just want to thank a couple people. Thank you to my family and my 2 older brothers. I want to say a big thank you to Margaret Landis. She's been the best mentor I've ever could have had. And all my friends, David and Delaney and Clayton, my brick. And thank you to Dwayne for making me feel what a prison can really feel like sometimes. Thanks.
Ricardo Silvestre.
I just want to quickly thank my mom and dad for going way out of their way to support my studies here.
Trevor Sotosanti.
Just want to say thanks to my family for coming out here, all my friends here that I've made along the way. It was quite a ride, and yeah, thank you so much.
Sofia Suarez.
Thank you, Grandma. We did.
Olivia Todd. Mackenzie Whitley. Justin Winstead. Graduates, really proud of you. Congratulations.
Okay, do something now. Next, I would like to call to the podium Professor Julie Comerford, who's the Associate Chair for Graduate Education at the Department for the Master's and PhD recognition.
Thank you. Graduation is the greatest holiday of the year, isn't it? This is like, I love this. Okay, so it's my honor to announce the graduate degree recipients. I'm going to call each advisor and student pair to the stage. The advisor will have a chance to say a few words about the student's work, then they will hood the student, then the student will have a chance to say a few words as well. So I'll begin with the Masters of Science students and then call up the Doctor of Philosophy. So beginning with Michaela Huffman and advisors Dr. David Brain and Dr. Kelsey Singer.
Hey, hello everyone. This is Michaela, and Michaela will have no trouble introducing themselves and telling you about themselves, as they are very outgoing and gregarious. Wonderful. And it's been an absolute pleasure to work with Michaela. Oh, I can stand up. So far, I would just want to tell you 3 or 4 sentences about Michaela's work so far. Michaela's thinking about comets and asteroids, but not in the fun way. The way in which they crash into Earth or Venus or Mars and hurt their atmosphere. Maybe they make the atmosphere blow away to space. Maybe they make the atmospheres even thicker. And so Michaela has compared lots of different models in scientific literature and successfully proven that nobody agrees. So for the rest of Michaela's degree here, Michaela will move on towards Michaela will make their own model and use it to test ideas about what's happened to the planet. Proud of your accomplishments so far and looking forward to what's next. Also, Michaela started Brazilian Jiu-Jitsu and is winning medals. Okay.
Hi, guys. I had a few words. When you look out into the night sky, over the void of space, held to Earth, tether of gravity, you feel small. I think everyone here. But then you can look to the moon, that we put people on the moon. Space reminds us that even though we fall individually, we work together, we can do. So here I am working on my little part of the big group project. Well, and I wouldn't be where I am today without Elsie, the faculty. I'd also like to thank my friends and my partner. So thank you guys so much. Next up, PhD.
Next up, Master of Science to Samantha Rosenfeld and advisor Dr. Alicia Clark.
I promise every professor here supervises students for master's theses, but I happen to work with a bunch who came in the same year. And I'm actually really happy that I got to work with Sammy, not as the direct supervisor of the research, but Sammy's advisor, Alicia Clark, is in the biology department. I'll tell you in a few sentences what Sammy did. And I had the privilege of being the in-department advisor for Sammy's work. So Sammy is an experimentalist, and she wanted to figure out the goopiness of the stuff that is inside Earth's mantle. And so she filled a big box with the kind of stuff that's inside Earth's mantle. And then she had gold spheres that she dropped into that box. She took pictures of them as they fell through the goopy. And by tracking their descent through, I stop saying the word goopy, viscosity, the viscous stuff. And by tracking that, she could figure out the viscosity of the kind of stuff that's inside of Earth at different temperatures, not room temperature here, but at high temperature as well. So it was really impressive work, something that I think Sammy is uniquely capable of. There are only a few people in the world who can do the kinds of things that she did, and we're super proud that she earned her master's degree.
I did not know that. But she
Moving now to the Doctor of Philosophy, which is the highest degree awarded in astrophysical and planetary sciences. I'd like to call up Angelina Harkey-Hosman and advisor Dr. Joel Ullum and Dr. Nils Halverson.
So I was Angie's titular advisor here at CU Boulder, meaning that I mentored her as a faculty member here. Her day-to-day work was supervised by Dr. Joel Ullum at NIST, right down the street. Angie studied the thermal conduction of phonons in dielectrics, and phonons are particles of sound. And she also studied what are called NIS coolers. That's normal metal insulators, superconductor junctions, and how they can cool sensors, very sensitive superconducting sensors on a device. And you might ask, what does this have anything to do with astrophysical and planetary sciences? And it has a lot to do with it, because these sensors are very some of the world's best devices for measuring ancient light from the Big Bang, called the cosmic microwave background. And the technology that she was developing has promised to serve on future space missions to understand the early origins and history of the universe, measuring that light. So I'd like to, on a personal note, I really enjoyed mentoring Angie when she was at CU. She came in bright-eyed and bushy-tailed. And when I asked her what she wanted to do for her PhD, she told me, quote, "I want to do it all." And she succeeded in narrowing down that scope of work a little bit, and is just a wonderful researcher and a wonderful person. So congratulations, Angie.
Back. Hi, everyone. So, as Nils mentioned, I had the privilege of completing my scientific training at NIST with some of the most brilliant scientists who are the world experts in what they do. Everyone there is also exceedingly generous with their time. If I ever had any issues in the lab, I could go around and just find whoever happened to be working on something in a different lab and ask them if they were busy. They would lie to me and tell me they weren't, and then would come follow me into my lab and help me work through whatever problem I was debugging. So that was a true privilege. And during my time here, I've been lucky enough to have essentially 3 advisors: Joel Ullum at NIST, whose incredible intuition guided my research while I did my thesis. I also had a second mentor at NIST in Hannes, who took his role very seriously by providing very many coffees. And then, of course, I had Nils, who served as my emotional support advisor in some ways, as well as a sanity check. And that's all, even despite the fact I don't think he really had to do any of that at all. Yes, so thank you to Nils. I'm also very blessed to have had such a strong support network in my family who have really showed up in force today. including my sweet mom, my goofy dad, my loving, supporting partner, Sean, my stepmom, Sandy, sister Lacey, Uncle Brian, Aunt Donna, and Uncle Bob, and my Auntie Barb. We couldn't even get them all into the planetarium today. Yeah, so I am truly, truly blessed. And I would not be standing here today if it wasn't for each and every one of you. I hope you know that. My tenure here as a graduate student has been made infinitely better by my union and the dear friends that I have made while organizing. And I would like to commend the Department of Astrophysical and Planetary Sciences for being a haven of compassion and quirkiness in academia. As some have mentioned, right now is an especially scary time to be a scientist in the US when our government has proposed cutting the National Science Foundation and NASA budgets in half, while increasing the amount of our tax dollars funding a war machine that has been turned against young children half a world away. I, too, in these times, turn to Carl Sagan and his infinite wisdom, and so I would like to share a quote from him from an interview done in 1989, where a CNN reporter asked whether or not Carl Sagan asked him if he was a socialist, and this was his response. I'm not sure what a socialist is, but I believe that the government has a responsibility to care for the people. And I'm not talking about doling, I'm talking about making people self-reliant, people able to care for themselves. There are countries which are perfectly able to do that. The United States is an extremely rich country. It's perfectly able to do that. It chooses not to. It chooses to have homeless people. We are 19th in the world in infant mortality, and I looked it up. As of 2024, we are 54th in the world. 18 other countries have saved the lives of babies better than we do. How come? They just spend more money on them. They care about their babies more than we care about ours. I think it's a disgrace. This country has vast wealth. Just look at something like Star Wars, where he's referring to Ronald Reagan's unsuccessful mission defense system. We've already spent $20 billion on it. And if these guys are permitted to go ahead, they will spend $1 trillion more on Star Wars. Think about what that money could be used for: to educate, to help, to bring people a sense of self-confidence, to improve not just the happiness of people in America, but their economic standing, to improve the competitiveness of the US compared to other countries. We are using money for the wrong stuff. I owe so much to Carl Sagan, as well as personally Kurt Vonnegut and Ursula K. Le Guin, because they remind me of the beauty and the absurdity that is humanity, our species, and that despite all of our troubles, a better world really is possible if we take care of each other. Thank you.
That concludes our graduate program, so I'll hand it back to Professor Brain.
Okay, thank you very much. And now we have a very special section of the program. It's an In-N-Out Burger section of the program that you just have to know about, but wasn't printed there. So I'll call back to the podium Professor Madigan.
I made a mistake. I skipped a student on our program in our undergraduate section, so I have decided to award that student, as a token of an apology, a PhD. Well, we'll see what happens. But yes, I did make a mistake and I skipped a student, so I think we can all give our biggest round of applause of the event yet to Brendan Chamberlain. I'll just be back up now and again. But.
Great, thank you. I told Professor Madigan on the side that I skipped a student one year that I was doing this, and it was a student who worked for me in research. So that wasn't so good. Great. Okay, with that, I'd like to do just a couple of things. First, I'd like to tell you that Summers Balch Observatory just up the hill is open now if graduates and their families would like to go visit. And it will also have a viewing night just for graduates and their families this evening from 8 p.m. to 10 p.m. The accessibility is a little bit of an issue right now. The construction work that was going on leading up to the entry of SBO, we were assured would be done by today, which means, of course, it's not done by today. But you should still be able to go up and around the speech and hearing sciences building and up the drive to SBO to make sure that you can access it. So you're welcome there. The other thing is, thanks so much for participating in the ceremony. We're really proud of this ceremony here in APS, that it has a little bit of a personal touch, that every student is welcome to speak if they would like. We spend time honoring students receiving graduate degrees and give them a lengthier chance to speak, for advisors as well. I know that makes it a little bit longer, and we really appreciate your patience. And then one other thing is that when we leave, there will be a recessional, so it will be faculty first, followed by students. And then students on your way out, I think that there's a mug, something like that. Grab the mug, but keep walking all the way out of the building and far enough away from the doors that your guests can also come out of the building. The guests will come out of the building and keep walking far enough away from the doors that the guests behind you can also come out of the building. And then we will do pictures with graduates and faculty together in a big group. And then the faculty will run away, and you can do, we will be on the sides. And then you can take pictures of the graduates, and then they'll throw their hats, caps, mortarboards, things in the air. So you don't want to miss that part as well. I think those are all the logistical instructions for now. We have refreshments out there for everyone. So the last thing I'd like to do is give a really warm round of applause and congratulations to all of our graduates one more time.